Get ready to master lockout relays, designated as ANSI 86, in this essential protection course meticulously prepared by engineer Sharif Hussain. Whether you are an experienced electrical engineer working in substations or a dedicated student learning about protection relays, this content will demand your full attention because lives and critical electrical equipment truly depend on understanding these vital devices that prevent catastrophic failures in power systems. A lockout relay, known as ANSI 86, is fundamentally a mechanically latched relay designed to operate decisively and permanently trip and lock out circuit breakers in response to a severe or critical fault condition within the electrical system. Once this relay has operated and latched into its tripped position, it remains in that state, ensuring the system stays isolated until a qualified operator performs a manual reset, thereby preventing any automatic re-energization that could lead to further damage or hazards. The operation begins when a primary protection relay detects a severe fault in the system. Next, this trip signal is sent to energize the coil of the lockout relay, causing it to latch mechanically into its operated position. Following that, the multiple trip contacts of the lockout relay open, simultaneously tripping the associated circuit breakers to isolate the faulty section. Finally, the equipment remains securely locked out and cannot be re-energized until a manual reset is performed by authorized personnel to confirm the fault has been cleared and safety is assured. The logic behind the lockout relay is straightforward yet critically effective. A trip signal originating from a protection relay activates the lockout relay, designated as 86, which in turn sends trip commands to multiple circuit breakers, such as CB1, CB2, and CB3, ensuring comprehensive isolation of the faulted area. To restore operation, a manual reset input is required directly on the lockout relay, emphasizing the deliberate design to mandate human intervention before any re-energization occurs. Lockout relays find their most critical applications in scenarios demanding the highest levels of safety and equipment protection, including transformer internal faults where internal damage could lead to explosions or fires, generator severe faults that threaten power generation stability, busbar protection trips to isolate short circuits in substation bus systems, and breaker failure protection schemes that address malfunctioning circuit breakers. These relays are indispensable wherever preventing automatic recluse on persistent faults is paramount to safeguard personnel, infrastructure, and reliable power delivery in substations and power plants. Routine testing and maintenance of lockout relays are crucial for ensuring their unwavering reliability in protection systems, encompassing a comprehensive mechanical operation test to verify the latching mechanism functions correctly under simulated trip conditions, and a meticulous contact continuity test to confirm that all trip contacts maintain proper electrical continuity when the relay is operated. These standardized procedures, aligned with industry practices, are vital to detect any degradation early and uphold the integrity of the overall substation protection scheme. Let's review the key concepts. Why must lockout relays be manually reset? Precisely to ensure that the underlying fault has been thoroughly investigated and cleared before any attempt to re-energize the equipment, avoiding the dangers of automatic recluse on uncleared or intermittent faults that could result in arc flash, equipment destruction, or personnel injury. Where are lockout relays primarily used? In high-stakes critical safety and equipment protection scenarios, such as transformer faults, busbar trips, and breaker failures, where they prevent hazardous re-energization and enforce operator verification as per standards like IEEE C37.90 and IEC 60255. To deepen your understanding of engineering principles made simple, be sure to follow me for more insightful content like this on protection relays and substation operations. And please share this video with your fellow engineers and students who need to grasp these life-saving concepts. Follow me and share the video for Engineering Made Simple.